Well, good morning again. Got derailed a little bit yesterday, but here we have the first part of Auctionorama. And what we have here are three 438A power meters, a 3400A RMS voltmeter, a 435B power meter, a 435B-HO4 power meter, and that's a pretty interesting one, and we'll take a look at that just in a little bit. And then a 432A power meter. Now, why did I buy these? Well, I bought a bunch of stuff at this auction. It was a large test equipment place, went out of business. But when I saw these, they looked in a bit better nick than my one, and so I thought, well, great, I'll grab those. That'll give me four. I'll pick the best two, one for myself, one for my father, and then I'll dispose the other two on eBay. I've wanted a 3400A voltmeter for some time. These things, I believe, go up to 10 megahertz, which makes them nice and useful for a bunch of the calibrations and performance testing on HP gear. These power meters, I didn't really want these two guys because I have them already, but we'll see if they work. And then I can see here that the on-off switch has already been taken out of this, so I suspect this guy's been cannibalized. This guy here I know virtually nothing about. However, I think it has it's probably designed for a much more accurate measurement than the standard 345B. So anyway, let's take a quick look at these actually in operation. Okay, so here we have the first item that we're going to go take a look at, which is the 3400A RMS voltmeter. You can basically see that it has a BNC input, and then it has a scale that's calibrated in volts as well as dB. And so what I'm going to go do, if we flip it over, what you'll see is that this also doesn't have the older HP plug on it. So let's make sure that it's 150 volt, and it is. So let's just plug this in, and then we can see that yes, it does turn on, and we can see that there's a little bit of meter movement there. So, which seems a little bit disconcerting, but anyway, let's plug it in. I'll switch cameras and we'll see how we go. Okay, so we should be able to see it. Does it have the? Oh, yes, it does. Let's pull the little stand out in the front here, and there we go. So we'll set it on the 1 volt range here, and so you'll notice it's already bouncing above 0 a bit. So if we put in, I have my let me set my frequency. Let me set my amplitude to 1 volt RMS, and then turn the output on at 100 kilohertz. So we're looking a little off. Let's go to 3 volts there and see what it does. Okay. Set that to 3 volts RMS. Nope. Okay. So at least the unit is doing something, though at 10 volts that should be around about here. Let's try 0.1 volts RMS. Yeah, so looks like, we've got a little bit of, some problem here. We can see that on 1 volt it should be 0.100 millivolts. Well, it's now settling down to around there. So this probably just needs a little bit of work on it anyway. That's fairly. Oh, you just try 200 millivolts there. Yeah, this probably has a little sticker on it if we look over the side that says 2002, which is probably the last time it's been calibrated. So more than likely it's just been sitting in the shelf there for quite some time. So I think we'll put that aside, and that'll become a nice repair video. All right, let's take a look at one of the power meters. Okay, so I want to take a look at this guy here. But just before we do this, let me show you the difference so that you can see what we're looking at here. Firstly, on this unit here, you'll see that this is a 435B, and this says 435BH04. Now, I've been unable to find anything that talks about what the H04 is, but I suspect that it is a custom high accuracy meter for some form of test rack. And the reason I think that is, if you look here, you'll see on the normal one, you'll see that you have the sensor input at the front and the power output that you reference power, because these things are open circuit, so you have to closed loop, so you have to go and set the reference to the power sensor so that it knows what it's displaying. And if we turn this around in the back, what you'll see here is the power references on the back and the power sensors. Now, that's normally an option that you can get on these guys, but clearly this has been built a bit differently. Now, the calibration factor, normally on this, if you look at this little switch here, it's a very coarse calibration. It does like 96, 97, 98, it's 1%. What we have here is a factory, and this is a little loose, so we'll pop this over and take a look. But what we have here is a little factory knob. And if we just lean that up, you see a little factory knob there that lets me get, in a vernier sense, very, much more accurate. I can go, 88.7. So you'll get very accurate calibration factor. So if you look at let's take a look at a sensor, and what you'll see here is you'll see that you typically will have these 1 decimal place calibration factors. So this lets you get the sensor very, very accurately, as compared to the coarser approach that was on the typical 435B. So let's take a look inside. Okay, so here we are. We're just looking inside the unit right now. I've shown you this before when we looked at these previously. This is the reference oscillator here. This will be the 50 megahertz 0 dBm reference oscillator, and that'll be cabled. You can see the little cable just there, and that will go out, and that will come out the reference port here on the back. What we have here is the cal factor switch is interesting because it's clearly loose, but let's see how that actually stays in there. I would have thought there would have been a little, so if we can see, if we turn it over on the side and just zoom in a bit, you can see there's the wire, and so we just pull that out, very carefully. Oh, I see. Okay. So let me zoom right in. Okay. Now if you pull this out, you'll see there on the side, that little hole there has had one of those clips that sort of fold back up, and so that's broken off. So I'm going to have to do a little bit of work to get that back in there. Otherwise it looks pretty much how I remember That's my other camera turning off. Otherwise it looks pretty much how I remember the other ones looking in here. You know, so let's just pop the top on that other one here and we'll take a look inside and see what it looks like. And we'll just see if there's any actual major differences. Always use your policy drive. Okay. Okay. If we take a look at the boards, this is a little bit, let's see, you can probably see this has got, it's either been repaired, but this has got a can instead of a dip. Looks like a lot of the same components in there, so I suspect that the primary difference you can see, you know, if we tilt up in here, you can see in here that's where the calibration knob comes through. And if we bring this guy over and tilt it up, you'll notice that there's just simply no knob there, and it's going into a board on the bottom, which you know, this one does as well, but it doesn't seem to. It seems to be dodging part of that completely. So, okay. Well, it looks fairly similar. So, I suspect that they are the same. This is just simply a little bit more accurate in terms of the cal factor. Well, you know, that's another good repair video that we'll have when we go and have a look at fixing this guy. So let me put these back together and then we'll take a quick look at the 432. Okay, so here is the 432, and you can see that the on-off switch has been taken out, or at least fallen in there. You know, we can see that arsenal movement still moves. Everything else seems to be okay. So let's pop the top and take a look inside. This is not an original screw, so somebody has been in here at some point. This is a PC screw from, like, you know, when you put a PC case together. So boards seem to be in there. Somebody's screwed those boards back in. Let's yep, I can see what they've done. If we take this, wow, interesting. It's a bit of a funny colour effect on the side there. Wonder what's going on. We see the little cowboy stickers are broken on here. So again, I don't know if there's anything wrong with this unit, but you know, if we look inside there, somebody has just cut the switch off. So I'm not sure if the switch has 2 leads or 4. I don't know if there's anything else cut off, but everything else looks okay. If we take a look at the board, there doesn't appear to be any, you know, if you look in here, there doesn't appear to be any missing components, so it doesn't look like somebody's been in there and buggerized around with it very much. Now fortunately, I actually have one of these as well, so what we can do is we can try powering this up and see how it goes, and see if it works, and if all it's been is somebody's needed to replace the switch on another one. Seems a bit strange they would destroy this unit. But anyway, see if they just need to replace that. And then what we can do is, you know, if it doesn't work, we can maybe swap out some of the boards and see what goes on. This also will be a nice little repair video. So let's go put this back on and take a look at the 438. Okay, so I'm not going to go through these because these seem to be all roughly about the same quality. But let's just turn one on and see if it okay, well, we're not getting any display on that guy. Okay, so we just have one repair there. Now for number 2. Okay. Well, at least we're getting display this time, so you can see the values there. Let me grab a sensor. Okay, so now just plug a cable in. Now I actually, out of the 2 meters, I actually prefer, you know, if I was having just 1 meter, the 437, I think it's just a better meter, a better user interface and experience. But this has the 2 channels. That really does make some of the coupler measurements much easier. Okay, so let's preset this. Let's 0 the unit. It's taking a little longer to 0, but there you go. Alright, now let's do the cal adjust. So now I've got to do cal adjust, and the cal factor is going to be 99.0, and then put that actually on the output here. Okay, come on. Something might have. There we go. Okay. There we go. Now if we hit enter, you'll see that the light's coming on telling us that the power reference is on. While we're waiting for that, let me. Okay. So let's change that. So if we turn that on, we should get 0 dBm, which is what we sort of expect. Okay. And now let's do 1 gigahertz. So I'm going to go cal factor is going to be 99.3, and these cal factors will change for each individual one of these. And let's drop this. Okay, so it's reading a little low. I just put it on my let's put it on my 8657B, and I know that's a bit closer than that, so but that's half a dBm down. That means that this thing's going to be a little bit out of whack. So I don't have the actual, I have a 432, but you're supposed to have a very low SWR, 1.05 or less to be able to means that I have about a 1.07 or so at 50 megahertz. So I'll be able to scroll that in a little bit more accurately, but that's good. This seems to be working here. Let's just turn that power off. Let's take that out. Let's try channel B and just see if that channel B works. Okay, we're going to go 0 that. Now, technically you shouldn't be swapping these things around while you're zeroing, but okay. And the cal factor, cal adjust was 99.0. Enter. We see a little light come on again. Okay, great. So let me set the cal factor of 99.3. Yep, and that's what I expect. You know, the log error is basically, you can see the cal factor up here. Log error is basically telling you that it's got very low input power on that, you know, the logarithmic input. So we put that back, turn that RF on again. 0.46. So this looks pretty good. All right, let's just power up that last one and take a look. Okay, this one's a little unstable because it doesn't have one of the rear feet, but let's power this guy on. And here we go. Channel A again. So I'm not going to bother you know, calibrating it and everything. I'm just going to make sure that it zeros and its calibration reference actually works. Okay, so that's what you'd expect. Okay, so let's turn this guy on. Yep, and this is even further off because you would. Oh, hang on, no, I need to cal adjust. So you want just 100. Okay. And there you go, you can see that's now 0 dBm. So, alright, channel A works, let's turn that off. Let's go to channel B. Channel B. Okay, let's zero that. Okay, it's zeroed, so let's do cal adjust, and we're just going to do 100. Okay, now if we turn that output on, 0 dBm, 1 milliwatt. Nice, alright, so it looks like we got 2 of these units that will work. So we got some good repairs with the 3400A and that 345B and the investigation into that, and then maybe a repair video for 4388. Anyway, that was part 1 of the Great Auction Score, and I'll be back with part 2 soon. Alright, hope you enjoyed that. Catch you later. Bye.